Welcome back. Here I'm going with 1 teaspoon, I guess it's a teaspoon, of bicarb soda. I'm also going to go with 1 teaspoon of ammonium chloride. That in there. That's chose to use ammonium chloride over sodium chloride, just for convenience because I've got it. I'm also going to go with 1 teaspoon of sodium bromine, NaBr. Quite heavy, that one. Oh no, it's crusty. Magnesium sulfate or Epsom salt. And that will be our electrolyte. Here I've just added some tap water. The temperature is a little bit cold. Oops, just spilled it up everywhere, Pete. And we're going to have to stir it a little while. It'll make quite a concentrated solution, and we'll have to check the pH, so I might just do that actually. I'll give it a stir for a while and let it clear up. Righto, the pH of that is pretty much neutral, so maybe a tad acidic, but gee, not much. So that's pretty good. And now I'm going to, that's clearing up quite well. I'm just going to divide it in 2, and I'm going to add some, just for good measure, magnesium concentrated solution of magnesium chloride and top it up with water. It's about right, pretty good. Bit of magnesium, hang on. All right, whack about 100 mils or 50 mils of, just 50 mils will do it. Concentrated magnesium chloride. Now we're getting a reaction. That could be hydrogen being released. I don't know. Righto, interesting. Very interesting. I'd say that was probably hydrogen. Where's my lighter? Hang on a sec. All right, let's try this. Indeed, it's hydrogen. There you go. Wow, smells good. Wow, that was a pearler. Here's a bit of rag I cut up, rolled it up into a bit of a roll. That's going to act as our salt bridge. So this is a bit of magnesium rod out of a water heater, and from the days when I was doing a Bedini type Epsom salt copper magnesium everlasting battery, although they're not everlasting, but anyway, it's good fun to do those ones. Just whack a hole in there with your drill, screw your screw in, negative terminal right there. We just need a positive terminal, which will be our carbon graphite rod, I think, if I can find it. Well, it appears that I've got some hydrogen coming off the bottom of that electrode. I've got them both in the same drink here, because I'd like to just do a quick test on our multimeter. Hang on, I'll come back. Okay, so I'll put that negative electrode on there. And we have 1.7 volts. So as it stands, the current's quite low, probably 2 milliamps at the moment. So here I'm going to charge it with this 12 volt battery that I used, or have been using for use with my Newman motor over there. And surprisingly, it's still on 12.27 volts, which is a little bit interesting, the fact that it's kept its charge. Anyway, so we're going to use that. I'm going to hook him up, and we're going to use that to charge. So hydrogen bubbles coming up. I think that was to be expected. So here we can see a slight change in the water. Maybe that one's a little bit more yellow, and that one's clearer. Also, difference is there is a significant amount of hydrogen coming off that sacrificial anode. Yeah, a lot. Which is interesting, I guess. Probably not what we want if we're making batteries. But if we're making hydrogen, yeah, she seems to be a pearl. I say. You can see that will last, in fact, quite a long time. Anyway, I'll just let that carry on. Okay, let's have a look. Yep, swap ends. The positive connected there. We got two, hang on. Shouldn't say overload. Because 2 volts. Yeah, I've got it on 2 volts setting. We got 2.2 volts. Yeah, 2.2 volts. And holding, so that bromide's doing its job. So here I'll be doing 6 volts at 100 milliamps. Still hydrogen. You can see it's drawn a fair bit. Current is dead short. There you go, 20 milliamps. So not a lot in it, but probably will last a while. With that, it'll certainly hold that voltage, that's for sure. Anyway, thought you'd find that interesting. Thanks for watching. Catch you later. Here I've actually added some zinc bromide that I had already charged. And I'll put in maybe 100 mils in both. But just watch this, Immediately, huge reaction.